Welcome back. So I'm gonna be explaining this code. We are using the Max 10 of Quartus Prime from Intel. So this is a program for an Fpga, and this will work as a clock divider. So the name of this VHD is CLK deep. So it's a short version of clock divider, as you can see. Now we are using three libraries. So the first one is the same one as we have used this entire time. Is this logic 1164. The second one is the ARITH, and the third one is the logic unsigned. So now I'm gonna be explaining the first part of this code. This is the part where you initialize the ports, so the inputs and the outputs. So basically, the CLK 50 megahertz is an input using the STD logic. Now we are using the RST as a restart, and this is an input of STD logic, as you can see. And finally, we are using CLK out for out and STD logic. And we use point dot for this part over here. And then we end with a CLK divider or clock divider. So we initialize and we finish it. So basically, the second part of the code is the architecture, and we'll explain how this system will behave, how will be specifically in the process. So it will be the sensitivity in the FPGA. So basically, we use the behavioral of the clock divider. So the signal is clock, temperature, STD logic, vector, 25 down to 0. This means that the clock divider will work essentially from 0 to 25. 25 is approximately 1 second, where it's not. And so here we put the zeros corresponding to 26 because we put this 25 down to 0. So here are 26 zeros. Now we use the alias clock new to specify how many of these block over here we are gonna use. So if we want to simulate this program, we will change this to 2 because we want to see this thing working very fast. But if we want to program FPGA and we want to see the LED turning on and off in time, we will have to use a bigger number. In this case, I'm using 25 as the maximum, so it will be 1 second on and 1 second off. But also I recommend to use 22 or 20. So now we are gonna be talking about the sensitivity of this parameter. So it starts with begin, clock divider process, CLK 50 megahertz reset. So in the begin, if reset is 1, then it will be 0, as you can see. Else if clock 15 megahertz event and clock 50 megahertz equals to 1, then the clock temperature will be the clock temp plus 1, as you can see. And it will end the if. And also it will end the process of the clock divider. So now we have the logic of these parameters. Now the clock out will be a change for the clock new, as you can see. If we don't use this part of the code, it won't work. Trust me, you have to use this part. Now, and the behavioral. So this is all for the BHT. Now I'm gonna be explaining the BHT. So this is auto-generated by Quartus Prime, and the only part of the code that I change is this, where it says code executes for every event on sensitivity list. So it will be changing over and over again. So in order this to work, we're gonna initialize this with a begin CL key loop equals to loop. Now the CLK 50 megahertz, if 0, it will wait for 10 nanoseconds. If 1, it will wait for 10 nanoseconds and will end the loop. So it will be over and over and over again. So I hope you learned something from this explanation, and now I'm gonna be testing this out in the Fpga. So thank you for stopping by.
Hello, welcome back. So in this video I'm gonna be explaining this FPGA university program. It's a Max 10 from Intel. So it is programmed with a frequency divider. So as you can see, it's changing to this first LED to 1 to 0, 1 to 0. And it has a time of 1 second. So it has two inputs, the clock that is in the pin 11, and also the reset that is the pin C10, as you can see. So if I pull up this switch, that is the pin of the reset, it will stop because it's a switch. As you can see, if it was a push button, it will be resetting and it will be doing again this 1 to 0 of the clock in this LED. But it's a switch, so it stops completely until I pull down this switch, as you can see. So it's pretty simple, and as it is obvious, the output is the LED. So this is everything for today's video. I hope you learned something.